Ladies and gentlemen, we're now going to continue with our next discussion. And this time it's going to be about robotics. Is robotics only for engineers? And this discussion's moderator is Anastasia Babarikina. The stage is yours.
Thank you so much. Welcome to our brief and very informative panel discussion called Is Robotics Only for Engineers? My name is Anastasia and I'm third year business administration student, and I'm going to reveal you a small secret. I was invited as a moderator just because I have no idea what is engineering and robotics. So getting back to the topic. Robotics is a rapidly growing field with more companies looking to automate. But we should not forget that robotics also involve design, construction, operation, details of both hardware and software. So can somebody without engineering degree like me, for example, handle it? And before we start sharing our opinions, I am going to introduce you to our guests. The first speaker is Emmanuel Merchant, and after more than 20 years working in higher education in the National Polytechnic Institute in his native Mexico, Emmanuel has recently joined TSI as Dean of Engineering Faculty, and his PhD comes from the University of Sheffield after completing research on soft computing techniques for path planning of multi-robot systems sharing a common workspace. Wow. And our second speaker is Kadiķis. He is a senior researcher and head of robotics and machine perception lab at EDI, where he has been working for 10 years. He has PhD in electronics since 2018, and also he's a member of EDI's Scientific Council. The main research areas are artificial intelligence and computer vision. This is also so curious. To say that I am impressed about our speakers today is to say nothing. So thank you so much for being here, and let's start our discussion. The first question is going to be very simple. What is the easiest explanation of robotics? How would you describe it to the person who never heard about it in the few sentences? The word to Emmanuel.
Well, I would say that the easiest way to describe robotics is how would you get a machine to do things that you are bored to do, or that you are wondering how would a machine do it. And it's just, how to get a machine to do things for you. That would be the easiest explanation that I can think of.
Thank you so much.
That's quite all right.
Yeah, I actually understood it so far. Yeah. And Robert?
Well, I'm assuming we know what robots are now. So anything to do with robots. If somebody is building a robotic dog, he knows mechanics, so he's doing robotics. If some programmer is programming a window cleaning robot, what it needs to do when it comes to an edge, then it's robotics. If somebody has a already built robot and wants to apply it in his production line, it's also robotics. So I would describe it as thinking about, developing, designing, programming, applying, teaching robots.
Okay, thank you so much for your answer. And we are going to go to the next question, which is, at which point of life did you both understand that you want to work in this field, to study in this field, and maybe you have a specific highlight in your memory you could share with us today?
Well, I think in my case, and probably it's very similar to somebody else who has studied engineering in general. When I was a kid, like many other kids, I wanted to improve my toys. And I remember taking them apart to see what was inside and try to make them work better, whatever that meant for me. I mean, most of the time my dad would get upset because I had broken a brand new toy. But, in my head I was an inventor. I was trying to make something to do very cool things. And then, when I was growing up and I was getting older, I realized that I actually needed to study, to understand why a mechanism is a mechanism, why a motor moves like it moves when you plug it into a battery. And then I thought, well, what if you were able to put A and B together? And then I found out about computer science. I started to program computers when I was very young, and now you made me feel old a little while ago. But I started to program a computer when I was 11 years old. And then I thought, okay, so I am inputting something here, and that thing is doing something there in the television back then. So what if I can put something here, and that thing will do it? And that was when I realized that it was something fun. Back then, I didn't know that it was called robotics. But when I had the chance to choose a major, I, of course, chose robotics engineering back in Mexico. And I think I have had a great time all this time.
Thank you so much. This was such a broad answer and super curious as well. And the same question to Robert.
Currently at TDI, I'm working on artificial intelligence, computer vision, and I'm doing that because I'm very curious about our mind, how it works, how can we replicate it, and how can we use it to do maybe some relevant and significant things in the world. And usually, before I came too close to robotics, I applied this field. I try to teach computers to understand what do they see in pictures, what do they see in videos. But then, a few years ago, I had the opportunity to apply it to robotics, to industrial robots, like robotic hands that are working in industry to build things. And it was quite an interesting experience to see how your code, how your intelligence that you give to this robot, how it manifests it in real world. Now this robot not only understands what's happening around it, it also can interact with the environment. So it was great to see how your code manifests itself as something that you can touch and that can also touch you back.
That's great, because I remember myself finishing high school and I thought I will never go in this field. Not because I don't like it or I don't respect it, it just seems so difficult, so I never tried.
That breaks my heart.
I will think about it after this discussion. Maybe I should change something in my life.
It wouldn't be something that you will regret, I can tell you that. It is exciting. Robotics is exciting. Very exciting.
Thankfully, I'm just 21 years old and I have so much time. Okay, thank you so much for these answers as well. And we will move to the next question, which is, what are your forecasts about this field, starting from Latvia and growing in the world?
Well, I think we need to point out that right now we are living in a world that is marked by artificial intelligence, robotics, and all those very nice fields, and it's something that is called the fourth industrial revolution. So the only way forward is to get involved in these areas of knowledge. Whether you are doing business, whether you are doing medicine, whether you are doing psychology, whether you are doing engineering, of course, you will be in touch with cyber-physical systems at one point or another. You actually are doing it now, and you don't even realize. So what is the future of robotics and all the other technologies associated with the fourth industrial revolution? Well, we are living immersed in a world, in a 4.0 world, in which if you don't know about robotics, it doesn't matter, because you will be interacting with cyber-physical systems, with robots all the time, and you might not even realize about it. So how is it going to grow? I think it's going to grow exponentially, because every single thing will be digitalized and will be requiring of people that knows about it, and that knows and understand the technology, and most importantly, they will know what to do with it.
Yes, I completely agree. I think, just to add, I think it doesn't really have much difference how it will develop in Latvia or globally. I think it will be developing everywhere, maybe with some different speeds, but the main result will be that robots will take over the world anyway. And yeah, not only for engineering people, because now, okay, of course, engineers are making robots more smart. The robots can now do more and more things that used to require human intelligence, used to require human dexterity. But it seems that robots will do many more things in industry, in production. They will plow and weed our fields. They will deliver foods. They will drive people. It's already happening in pilot projects. So in time, it will just become more robust, more cheap. And it will mean that, as already was said, everyone will interact with robots, and not only engineers, but we also will have probably robotic managers who will give tasks to robotic supervisors, robotic teachers, and so on.
It is going to be an era marked by technology and artificial intelligence. And if we want to have a glimpse of the future, what the future looks like, and if we have the chance now that we will be starting to travel again, it is worth to go to Japan to have a look at the things and how amazing the future for everyone else looks like.
All right, but I'm going to ask you, because it's just my personal question, do you believe this stereotype that Latvia could lag a little bit behind because of underemployment and maybe like lacking of education, lacking of budget or something like that?
Well, I mean, getting into robotics, of course, it requires two things. First, that someone is interested into getting into robotics, and secondly, that you have actually people that you can learn from. And something that I have learned, and the reason you asked me a little while ago, why was I here? Like, why did I come all the way down from Mexico to Latvia? And the reason that I came here was because a few months ago, I came to learn that TSI, where I work right now, had a very interesting program, first program in its kind, of teaching robotics here, because it's usually, robotics is always thought as a derivation from either mechanical engineering or electrical engineering or electronics. And the fact that I found a program that it's entirely and purely about robotics implemented in a university here in Latvia, in TSI, well, it tells you that people have recognized that as a priority. Whether we will see that the industry is ready. Those who do not robotize, digitalize, advance into the adaptation and adoption of all these technologies will be left out of the market. So there is going to be a need for people that knows about it and can help, maintain the businesses, maintain the workplaces here in Latvia, and of course all abroad, all over Europe and the world. I hope I answered.
Yes, of course. I really hope that my home country is going to be developed enough soon. I mean, it's also in this way going to be so soon developed, but I want to make it more rapid, maybe. So we should be more patient.
You are doing such amazing, great things here in Latvia about robotics. I mean, you have Robert here who's working in ADI. Okay?
That's right.
You have the people from RTU, you have the people from LU, you have the people from, of course, TSI. Latvia has won international contest on robotics. So the people are here. Nowadays, when you have access to information and knowledge without limit, it is something that you are doing, and you are doing great here. So you will be there. Don't worry about it.
Thank you so much. I'm calm now, I swear. All right, and let me ask you one of the main questions of this discussion. So can somebody without engineering degree handle robotics?
Well, I will let Robert take this one because I spoke a lot, Linda.
Okay. I think definitely yes. Maybe then I can introduce some things that we are doing currently at EDI as researchers, because one of the things we're trying to do is to make robots easy to train. For example, in our industrial robotics, we try to automate different production tasks. And usual approach right now is machine learning, sometimes called artificial intelligence. If you want the robot to pick up some object, you show the robot thousands and thousands of images of this object, so it can start to recognize this object in new environments, in new positions. Preparation of this data is very hard, long, manual labor, and to create this teaching environment, it also requires some specific knowledge. What we're trying to do is to make robots so that you show him this one object, a new object, it scans it or takes few pictures, and then inside computer, inside simulation environments, it creates thousands and thousands of images by itself and teaches from them. Or, for example, we're researching imitation learning. It means a human can take an object, do something with it, for example, put it in some tray, and the robot needs to repeat this, what human is doing. So it happens again automatically inside the robot, inside computer. There's simulation environment, gaming engines, where it all can be tried out many times, called reinforcement learning, and the robot can teach by itself. So the goal is to get such robots that can simply be retrainable by anyone. Also, our partners are working on gesture recognition for robots. So with gesture, you can very intuitively show robot what to do or commands to stop or continue and so on. But this is research, so it's maybe a few years in the future. But if we're talking about today, I think also you can definitely start doing robotics, because now the resources to do so are abundant. There's If you want to code, if you want to build, you can just go to internet, to YouTube, to Coursera, to Udemy, to Udacity, to you name it. There's thousands of blogs where you can start to do things, and programming is becoming more easy. If you're afraid of code, there are languages where you can use building blocks, which already have all these hard details done for you. You just put the program or put some steps that you want the robot to do, and you already will have something. And also, there are a lot of robotic kits and tools that are becoming very cheap that you can use to start building actually robots in your house. And also, as an example, my nephew is doing robotics. He's programming robotic Legos, and he doesn't have engineering degree. He may be in some 4th grade. So everyone can start doing that. There is some work to do before you get to industrial reliability, but this gap is becoming, I think, smaller and smaller, and the building blocks that you can use are so abstract that anyone can start to do even these technical things. Not talking about all not technical things like supervising, like interacting with robots and so on.
Yeah, I totally agree with Roberts. I mean, the question, is robotics for someone who is not doing an engineering degree? Totally. I mean, anyone can get into robotics. As you know, as Robert just mentioned, you know, kids, his nephew is doing a lot about robotics with these Lego kits, and there are many other kits. It actually depends on what you want, you know, at the end. As a hobbyist, you can learn a lot and you can get to do many cool things. But if you really want to get serious about it, then you will have to learn about mechanics, about physics, about electricity, about computing, for those things that you were already doing as a hobby, for it to be done even better. And you will realize that you are starting to see the machine, as Robert mentioned earlier. You know, when you write some lines of code, you know, how those lines of code actually make something move in a way that you wanted it, or actually to learn how to do something for you. And can anyone get into this, into robotics? Yes. But my advice to anyone who are considering to study robotics is like actually, you know, get into the university, follow a degree. If perhaps you might need to go into a master's or a PhD program, and believe me, you will be doing awesome things in the future.
Thank you so much. And I have a question from me again. For instance, I'm studying business. How can I get involved in robotics? What do you think?
Okay. Soon, we will have the need of managers that understand the use of technology to increase the profitable of businesses, all right? So you will need to learn and understand how all the technologies associated, not only robotics, but all the technologies associated to the fourth industrial revolution will have an impact on the revenue of a company. How can you identify a market gap that can be exploited and mean a revenue for a company and, you know, like the distribution of wealth by using those technologies? And usually people like Roberts and me, we are like engineers. We see a problem and we want to solve it. And sometimes we miss those little details about the market because we are so focused on trying to get something coded or something, you know, fixed. But we need people who are actually out there looking at the opportunities of the market. And that is something that sometimes researchers or engineers, we miss a lot. So you need to partner with someone like us, for example. You can partner with us at TSI or at EDI or at any other university, you know, technologically oriented university. And believe me, you can identify those market gaps that will be there to be used, you know, technology for a better future.
Wow, you made me feel very useful.
Of course.
Roberts, do you agree with Emmanuel?
Sure, yes. And this partnering with researchers and so on, it can begin very small. You have your problem in business. You can, in our case, you can just call, just come and ask a question. Do we see that like our research, our technologies is usable there? And sometimes it's a very important talk in the beginning because when we're working with industries and they have to solve some problems, sometimes the things that they think is hard, we as engineers see, oh, no, this is easy, we can do this no problem. But sometimes they think, okay, but this is like easy thing. And then we come, oh no, it's research for 5-10 years. So just to get this together to see which problems we can deal with now, where robots are ready or not, it's good to have this small talk. It's usually free. So at TDI, it's free always to just talk and see if there's some need for robotics or if it's possible to do something with that right now.
This is great that you admit that we should collaborate.
Yeah, I mean, there is something that everyone nowadays need to get familiar with, and it's big data. And big data will be used in business, will be used in healthcare systems, will be used by lawyers, will be used by accountants, and it means the digitalization of something. And that information, that big data, it's something that in business has a huge impact. So my advice to you or anyone who's doing business right now, it's get into the field of big data. That is going to be something that will open many doors for you in the future.
Great, great. And also, Roberts mentioned that your nephew is also starting something with robotics. I have also a story from my life that my little brother started like small courses for kids, but after a few weeks he dropped because he thought it's difficult enough. So maybe you have some advice for small kids, maybe for pupils, how not to lose this motivation to learn this field.
Oh, well, if this problem was that this was too hard, then probably it's just a thing of looking for another resources, because there's plenty of resources. Some are harder, some are easier. I'm mostly afraid that for kids it might not be so hard, but they may lose interest just because, okay, there's next big, shiny, interesting thing to do. But maybe it's good that you, in your childhood, take on many, many different things until you find something that really, really takes you. And if you find that, probably you won't get him off it anyhow.
I'd say that you should tell him that if he wants to become an engineer, he will have the chance to break many toys, put them back together, and probably even make them better, or he might probably even invent a new toy. So when you pick on the creativity thing, because we are all creative when we are kids. We are always wondering what happened if I put this in there, or what happened if I tie these two things together. We are all born engineers. Some way along the, your life, you start, getting interested in something else. But when you're a kid, you are a natural born engineer. We only need to continue nursing that spirit. And obviously not disappoint someone, but when someone, I don't know, if my kid, that he loves breaking things, he would break something and he takes it apart and he tells me that he did it because he wanted to know what was inside and why was it working like that, I will not tell him off. I will ask him what did he learn, and if afterwards I will ask him if he can put it back together, of course. But just tell your nephew, your brother, your little brother, don't be afraid of breaking things. Just don't tell mom or dad, but just break them. You're gonna end up being a great engineer.
Thank you, Roberts. Thank you, Emmanuel. I will literally cite you to my brother and tell exactly the same. It's very useful. And as we have a little bit more time, I'm going to ask two personal questions to Emmanuel first. So you work in TSI as Dean of Engineering Faculty. So could you tell us how demanded is this program among students? Could it be a little bit more demanded, or is it fine for now?
Well, in general, I think you can see something not only in Latvia, not only in TSI, but all over the world, and it is that we are always struggling to get the students into engineering. You yourself have told us that you were really into doing things like that, but then you thought it was way too difficult and decided to go in a different line of interest. Well, that is happening everywhere in the world, and we are trying to do every single country that I have been in, and like having a chat with people in charge of education in different countries. We are all trying to get people involved in STEM education, science, technology, engineering, and math, from the very early stages of education. Of course, right now there is a shortage of engineers in the world. Why? Because people are afraid of mathematics, of physics, about programming, so we're trying to make it fun from the very beginning. And I can tell you something, if you follow the Instagram of TSI, you might be surprised to learn how our students are posting stories about how fun and how easy it is for them to learn higher mathematics, for example. higher mathematics. Mathematics. People are excited about posting stories about mathematics being fun. Can you imagine that? And it's not something, like it is not someone who's been paid to post those stories. It's actually students who are enjoying mathematics. And just like Robert said, probably you had a bad experience if someone got disappointed about learning something. It's probably because they didn't have a good teacher. But we need to teach people to be resilient. And, you will have in life good teachers, bad teachers. Stick with the good ones.
That's very interesting, because I also had higher mathematics. I was not that excited.
Oh my God, you need to do TSI then.
Maybe, because I'm finishing this year, so I'm already thinking, what could I do next?
You will be welcome.
I will keep you updated. Thank you. And the personal question to Robert. Was there a time in your life when you thought that it's not your field and you could drop it? Maybe you had doubts.
Actually, no. Because, as I say, it's this perspective of this field, the potential value, it's hard to deny. You're seeing how robots are coming into everyday world, how artificial intelligence is used everywhere, cameras, computer vision, so on. And there's plenty of applications that you can work on. I was working on projects about mobility. So self-driving cars is the future there. Okay. So robotics and machine learning and so on. I was working on industry applications, the industrial robots, the arms that are doing everything is the future there. Then I'm also very fascinated with vertical farming in cities. And I see them also in the future as something automated, full of robots. So anything that I would really like to do, any problem I would like to solve, or maybe even business to build, I see that robots will be there. So I don't see that in the future few years, 10 years, I will go somewhere else. Somehow I will be related to robotics in anything I will do.
Yeah, your research about artificial intelligence, it already says a lot about you. It's super great. Thank you so much for doing that. And maybe you, Emmanuel, maybe you had this time in your life when you wanted to leave it.
No, from very early years in my life, I knew I wanted to do something related to machines. I was always with my brothers and my sister trying to make something up, like we were inventing things, and we had the chance to do it when we were kids. So, no, I don't think I have ever doubted being involved in robotics. I think it's something that it grows in you. And, we have a special little thing, people that like robotics, we have that little gene of a geek, of a nerd, of an engineer, someone who is probably not understood by many, because, people find it like sometimes odd. Why are you so into math? Why are you so into computer science? Why don't you go out and have fun? But for us, that's having fun. And then being able to talk about it in a conference like this, it's even more fun. And then we have a chance to go to very nice places. We were talking about going to, for example, Hawaii for a conference, for a scientific conference. Man, it has everything you might want in life. So no, I have never doubted to be a scientist. I have never doubted to be a roboticist. I'm just happy to have chosen that path in my life.
That was very inspiring, honestly.
Thank you.
Thank you so much. What a shame we have limited time and such broad, significant, and interesting topics, so we have to end soon. And thank you so much for being here. I really believe that soon the robotics will be a mandatory block at school, so there's no way we're going to escape it. And I also hope that soon I will find time to investigate more by myself. Thank you for joining this discussion. I personally feel a little bit smarter now. I hope the audience too. And we are finishing on this beautiful note our discussion.
We actually have, before we finish with that, we actually do have a question. We do have a question sent in to you both. What is the most challenging aspect of working in this field? What do you feel?
Well, the most challenging for me, it's actually get the requirements right, to understand what the customer wants to do, so you can actually solve it with a machine that will do what the customer wants, not what the researcher wants to do. Because a researcher always wants to do it his way, but his way is not necessarily what the client wants. So it is always down to translating properly, the need and the requirements of the client into engineering specifications.
I see.
And for me, it's also this maybe complex thing is this whole big picture because, okay, we have built a robot, it's mechanics, electronics, we have programmed it, it's machine learning and other programming frameworks. Then we put it together, we made it reliable on production line, which is field on itself. And it's complex system with many elements. And now you think it's like done, but how about ethical considerations? Okay, now there's even more to think about. So it's not something that we're afraid of. It's wide field, and you need to think about many things at once. So it might scare someone, but just do it, and that's all.
See. Well, thank you so much for this discussion.